Bismillahirrahmanirrahim. Well, students, the last topic that we discussed was regarding total internal reflection, and now we are going to start off with the applications of total internal reflection. There are three main applications, in fact 4 main, that are presently being used and which are given in your textbook. The first one talks about the totally internal reflecting prism. This is the first application of total internal reflection. The second is about optical fiber. The third is about a light pipe, and the fourth is the endoscope. We will discuss them one by one. The totally internal reflecting prism. First of all, please understand what is a prism. A prism is a transparent body having 3 rectangular and 2 triangular surfaces. Prism क्या होता है? एक ट्रांसपेरेंट मटेरियल का बना, या शीशे का या ट्रांसपेरेंट प्लास्टिक का बना हुआ एक जिस्म है जिसकी 2 साइडें जो हैं वो तिकोनी होती हैं. This side and the back one of it is 2 sides are triangular, and these sides are rectangular surfaces. I will come again. A prism is a transparent body having 3 rectangular and 2 triangular surfaces. 3 उसमें मुस्ततील नमा surfaces होती हैं और 2 ये वाली और इसके बैक वाली जो है वो triangular है, त्रिकोणी है, और ये surface और ये surface और ये surface they are rectangular. So that is a prism. Many optical instruments, they use right angle prisms to reflect a beam of light through 90 degrees or 180 degrees, such as cameras, binoculars, periscope and telescope. बेशुमार इंस्ट्रूमेंट, ऑप्टिकल इंस्ट्रूमेंट्स जो हैं वो राइट एंगल प्रिज्म्स को यूज़ करते हैं, और वो यूज़ करते हैं फॉर द पर्पसेस ऑफ रिफ्लेक्टिंग द लाइट. उनमें से which are the optical instruments that are using this thing, that are using these prisms? One is a camera, the second is a binocular दूरबीन, the third is a periscope, and the fourth is telescope. पेरिस्कोप में सतह समुद्र के ऊपर देखने के लिए submarine, a submarine has got a periscope. It protrudes out like this, and it can see the surface, what is there on the surface, and the person sitting over here can see it, and the instrument that they use in it is the prism that is used. And I'll explain you this phenomena. One of the angles of a right angle prism is 90 degrees. एक उसका ज़ाविया 90 का होता है. When a ray of light strikes the face of a prism which is perpendicular, it enters the prism without deviation. यानी ये आपने पढ़ा है कि जिस वक्त कोई रोशनी की शुआ 90 के ज़ाविया पर जाके स्ट्राइक करती है किसी बाउंड्री को, तो वो फिर it goes through without deviation, without any deviation, अपने हस्ता भटके बगैर, बेंड हुए बगैर गुजर जाती है, and strikes the hypotenuse. ये hypotenuse है. So this is a right angle prism, CDE. This side CD is the hypotenuse. This is the angle 90 degrees. That's why it's known as a right angle prism. And the ray of light comes from here, say from point A to B, and from A to this side, and from here it is reflected back at an angle of 90 degrees. And similarly the second B, from here goes and strikes over here. So a person over here can see the image from here. One of the angles of a right angle prism is 90 degrees. When a ray of light strikes a face of prism perpendicular, it enters the prism without deviation and strikes the hypotenuse at an angle of 45 degrees. 45 के ज़ाविये पे उसको स्ट्राइक करती है. Since angle of incidence 45, ये जो angle of incidence 45 है, ये since it is greater than the critical angle जो कि 42 degrees होता है, therefore the light is totally internally reflected by the prism. ये याद करने की बात ये है. Main point इसके अंदर इस टॉपिक में the main point is this thing that I'm telling you now. First thing is the application of total internal reflection. In it we use a right angled prism. A right angled prism has an angle of 90 degrees. The ray of light enters from this body, say this body is AB. When the ray of light from the point A and strikes this surface hypotenuse, it is reflected back as A dash. From B it goes and strikes at B dash. Since the angle of incidence is that angle which the incident ray makes with the normal, that angle is 45 degrees, which is greater than the critical angle of glass. Therefore total internal reflection takes place and the light can be seen from this point. Two such prisms are used in a periscope. पेरिस्कोप में जो कि एक डिवाइस है जो कि यूज़ होती है सबमरीन्स में सतह समुद्र के ऊपर देखने के लिए, उसमें ऐसी दो डिवाइसेस होती. Two such prisms are used. Two such prisms are used in a periscope. One prism is here and the second one is here. So a ray of light coming from here, the person sitting on the ground under the sea watches from here. The ray of light comes from here, strikes the surface at an angle of say 45 degrees and then goes back, strikes this second prism at an angle here and is reflected to here. So the person can see from here that what is there on the surface of the sea which is happening over there. So this phenomena in which you use the right angle prisms is, and two times you use it, is the periscope. I'll come again about the application of total internal reflection. First application that you have to use is about the totally internal reflecting prism. The second is about the optical fiber. Third is the light pipe, and the fourth is endoscope. In the totally reflecting prism, what you do is that a ray of light from here enters the body at an angle of 90 degrees, strikes the hypotenuse. Since the angle over here is 45 degrees, which is greater than the critical angle, therefore is reflected over here, and in this way you can, the ray of light travels like this and you can see it very clearly what happens there. I'll come again. Many optical instruments use right angle prisms to reflect a beam of light through 90 degrees or 180 by total internal reflection, such as cameras, binoculars, prisms and telescopes. Periscopes and telescopes. One of the angles of a right angle prism is 90 degrees. When a ray of light strikes a face of prism perpendicular, it enters the prism at an angle of 90 degrees without deviation, because the angle is 90 over here. And when it is 90, that helps because the angle of incidence 45 degrees is greater than the critical angle. Therefore, the critical angle for glass is 42 degrees. Therefore, it's totally internally reflecting. Two such prisms are used in periscopes, as I have shown you over here. The ray of light enters from here, strikes this surface at an angle of 90 degrees. Since the angle of incidence 45 is greater than the angle of critical, it goes over here and it can be seen over here. But in binoculars, the light is totally internally reflected by a prism by an angle of say 180 degrees. The next topic that we are going to discuss is about the optical fiber, and I would like you to make notes of it, and if you have any difficulty regarding understanding of this topic, please feel free to talk to me on these two numbers, 0333 5516 358, and the WhatsApp number is 0336 547 3312. You can send me an SMS also. You can write down your difficulties and send me the image of that. In either case, I'll talk to you, give you a ring and try to explain whatever difficulty you have. Make neat and clean notes, draw headings and diagrams, and please give the feedback to me if you have any difficulty. Thank you.